Section 2.9 is energy. So this is just going to be an introduction. We will be talking about this more later, but the definition of energy is the capacity to do work or transfer heat. So this could be anything from, energy production like we're used to, like electricity, burning of oil, nuclear power plants, or solar panels. It could be burning of fire. It could be the energy that's just inherent in the atom itself, which we can get out, we know, like for things like nuclear radiation and fission or fusion. It could be something like a car engine where we put in gas and then we get out energy as we drive along, or even in your body, right? So you eat food to give you energy, which we then can transfer both into heat and work, like we can move around. So chemistry really has most to do with potential energy, okay? So potential energy is stored energy. The other type is kinetic, which we're not really going to talk about here, but you will talk about a lot next year in physics. So stored energy, you can think of it as like energy in a spring. If you compress a spring, you can store the energy, and then you get it back out when it releases. The same is true with bonds. So there is energy that can be stored in bonds. This is due to the electrostatic. So electrostatic just means that a positive and negative charge are attracted to each other. And the bonds then can store energy, which we can get back out again. So we can see that sometimes because when energy is released, like in exothermic reactions, of course, like combustion, right? So when we burn a fuel, the fuel stores the energy actually in its bonds, and then when we burn it, we get it back out again. And the same is even true of like dynamite, right? So some of the reactions can be explosive, so we can store energy in those bonds, and then we get them back out again with a chemical reaction. So heat. So let's talk about heat. So what really is heat? Heat is the flow. We're going to talk about the flow of heat. It's usually represented by Q here. All right. Let's see if I can figure out how to draw. All right. So Q represents the heat flow. So the heat will flow from something of a higher temperature to a colder temperature. The symbol is Q. It is the flow of energy. It has the SI units of joules. And then this leads us to, we need to have some definitions in place to be able to talk about energy. So the system is part of the universe that we are focusing our attention on. So it could be something like the Earth, right? That could be our system that we're talking about. Or it could be something smaller that we define, kind of like an Erlenmeyer flask, where we might be doing a reaction. And then the surroundings are everything else. So we have two different types of reactions that we can talk about in chemistry that have to do with heat flow, right? So the exothermic is one that we're probably used to the most, where the energy will flow out. So that can be like doing a reaction where we see the flask will heat up, and then it will release heat. There are other types of reactions. There's the endothermic, and that's a reaction that actually gets colder, all right? So that's when heat is pulled in from the surroundings then, and it's actually put into, usually into the chemical bonds. And the last thing here we're going to talk about with energy is the conservation of energy. So we also have conservation of mass too, but conservation of energy says that in any chemical or physical process, energy is neither created or destroyed, so that all the energy we put in, we must get out again, all right? So there might be losses like due to friction or heat or something like that, but all the energy that goes into a system must be accounted for. So for example, if we put gas into a car, we then are able to drive it, right? And we get that out again. We use food to fuel our cells, right? So ATP provides the source of energy for our cells to actually do work and support our body. Then even like fireworks, right? So the energy is stored in the fireworks. We release it when we ignite them. When we ignite the fireworks, they explode. We get the explosion back out again, the energy back out again.